We're getting started on our trigonometry unit for Algebra 2, and the first thing I want to do is review right triangles. So we're going to review SOHCAHTOA, which you may recall from geometry, but it's a mnemonic that helps us remember the ratios of the lengths of two sides of a right triangle. So first let's talk about what trigonometry is. Trigonometry is the study of triangles. So we're moving on from algebra and geometry, and we're going to use a little bit of both, or a lot of both really, as we dive into trigonometry. What is a trigonometric ratio? A trigonometric ratio is the ratio of the lengths of two sides of a right triangle. So I've got a right triangle drawn here, and I've got the mnemonic SOHCAHTOA. Right under here, I have what you may recall as the Pythagorean theorem. The Pythagorean theorem is a formula that helps us find the length of a missing side, right? So a squared plus b squared equals c squared. If I know the lengths of two sides of any right triangle, I can use this formula to find the length of the third side. So what I'm going to do here is I'm actually going to label this right triangle, and I'm going to label the hypotenuse first. The hypotenuse is directly across from the right angle. We'll call that C, and it's the longest side of the triangle. It's the hypotenuse. The other sides represent the legs. So we'll call this A, and we'll call this other one over here, we'll call it B. And it doesn't matter which one I call A and which one I call B. Those are the legs of the right triangle. So how are these sides related? Okay, well, let's see. What I'm going to do is I'm going to draw a Greek symbol that's like the letter O, capital O, with a line through it. And that symbol is, or letter, is theta. We use theta, which is the Greek letter, to designate an angle when I don't know the angle measure. Okay, so this angle right here, theta, what I'm going to do is describe the legs of these sides where they are in relation to this angle. Okay, so the side that's directly across from theta is opposite. This is the side that is opposite to theta. The side that is right next to it is the adjacent side. So that's where that's what we'll call these legs now of this right triangle in relation to this angle theta. So I can use the mnemonic SOHCAHTOA to help me remember the trigonometric ratios for these sides. So first I want to review this. What I can say is that the sine of theta, so I'm going to say sine of theta, is the ratio of the length of the opposite side to the hypotenuse. So opposite to hypotenuse, which means the sine of this angle measure right here, the sine of theta, and I'm going to write it again, the sine of theta is the ratio of B to C. It's the opposite over the hypotenuse. So the sine of that angle is the ratio of this side over here over this side over here. So let's move on to the next one. Cosine. The cosine of theta, which, if you want them spelled out, there's sine, cosine, I'm just abbreviating them, and then tangent, which you may recall. I'm just abbreviating them. The cosine of theta is the ratio of the adjacent side over the hypotenuse. So obviously that hypotenuse, adjacent, there's the A, over the hypotenuse, there's the H. That's how we can remember this, SOHCAHTOA. So how I might write that is the cosine of this angle measure right here. The cosine of theta is the ratio of this side over this side. So A over C. I'm going to erase those lines now. And then the tangent of theta is the ratio of the opposite side to the adjacent side. So the opposite side over here, how it's related to A. So the tangent of theta would be B over A. And we're talking about that angle measure. So these over here, right here, these ratios, if I was talking about a different angle, like let's say I was talking about this angle measure over here, which I'm going to give a different symbol, a different Greek symbol. If I'm talking about that angle measure, the sine of that angle measure would be, well, the opposite side would be over here, right? So it would be A over C. The sine of theta is B over C. So you just have to look at what these sides are in relation to the angle that you're talking about. Okay, and so if I'm talking about this angle right here, this theta that I put a star by, I need to know that the side directly across from it, that's the opposite to that angle. Right next to it, that's the side that's adjacent to it. And then the hypotenuse is directly across from the right angle. So let's move on to some practice problems. So it says write the sine, cosine, and tangent ratios for angle A and angle B in triangle A, B, and C. So let's see. I know the first thing that I want to do is I know the length of the legs of this right triangle, but I don't know the length of the hypotenuse. So the first thing that I'm going to do is use the Pythagorean theorem, and I'm going to highlight that. I'm going to use the Pythagorean theorem to find the missing side length. The Pythagorean theorem is a squared plus b squared equals c squared. And we'll call this b, and we'll call this a. And if you did it vice versa, you called the other one a and the other one b, that's fine. Okay? I just know that if I square them and I add them, and then I take the square root of that, I get the length of the hypotenuse. So let's plug in our values. A is 5. So I'm going to plug in 5 for A, 5 squared. 3 is B. I'm going to plug in 3 for B. Square that, and I get C squared. 5 squared is 25. 3 squared is 9 equals C squared. 25 plus 9 is 34. So 34 equals C squared. Well, I don't want what C squared is. I want what C is. So I need to take the square root of both sides. So I get the square root of 34, or root 34, equals C. And I would try to simplify this non-perfect square root, but I can't simplify it any more than this. So I'm just going to call this length right here the square root of 34. That's the length, okay? So we use the Pythagorean theorem to find the length of that side. So now we can write our sine, cosine, and tangent ratios for angle A. So let's do that first. Angle A is right here, okay? I know, so a lot of times what you'll do, you know what? I said we could call, a lot of times whenever you have a triangle, okay, a capital letter will represent the angle, right? So I've got A, B, and C right here. So what you typically see is the side directly across from A is going to be like the lower, like we'll use a lowercase letter to describe the length of that side. And then directly across from B, we'll use a lowercase letter. So it was right that I gave the lengths of those sides A and B. But most of the time, that's what you see. So now let's write our ratios. And what I'm going to do is I'm going to write SOHCAHTOA right here. And I write that a lot whenever I'm doing right triangle trig. So SOHCAHTOA, that just helps me remember that the sine of this angle measure right here is the ratio of the opposite side to the hypotenuse. The opposite side has a length of 5, and the hypotenuse has a length of square root of 34. However, I would not leave my answer like that, because do we leave a radical in the denominator? We don't, so we need to rationalize the denominator. How do I do that? I'll put a little card in the upper right-hand corner if you need help rationalizing the denominator. There's a short tutorial video, but here's what ends up happening. I end up getting 5 times the square root of 34 over 34. And I know that seems kind of like an uglier answer, but that is the correct answer because we don't want a radical in our denominator. So now let's talk about the cosine of A. The cosine of A is the ratio of the adjacent side over the hypotenuse. The side that's adjacent to this angle or next to it is 3, and the hypotenuse is the square root of 34. And again, just like the sine of A, I don't want a radical in the denominator. So I'm going to rationalize the denominator, and I get 3 times the square root of 34 over 34. Now let's move on to the tangent. The tangent of A is the ratio of the opposite side over the adjacent, which is 5 over 3. And that's pretty simple. So now let's move on to the angle B. This angle right over here. When I'm talking about the sine of this angle, so I'm talking about a different angle, the opposite and adjacent sides are flipped. So the sine of angle B is going to be the ratio of the opposite side over the hypotenuse, which is now 3 over the square root of 34. Which, do we want to leave the radical in the denominator? No, so we're going to rationalize it, and we get 3 times the square root of 34 over 34. Now let's move on to the cosine of B. The cosine of B is the ratio of the adjacent leg to the hypotenuse. Well, the adjacent leg is right here, and that's 5 over the square root of 34. And we want to rationalize the denominator, so I get 5 times the square root of 34 over 34. And now the tangent of B. Tangent of B represents the ratio is the opposite side over the adjacent, which is now 3 over 5. So yes, as you can see, when we switch these angle measures, our ratios switch too, right? And I do want to make a little note. I want you to make a little note on your notes so that you remember to do this on your assignment. But just remember to rationalize the denominator. Remember to rationalize. Oh my gosh, I totally spelled that wrong. Let me try to do that again. Rationalize. There we go. The denominator, and I'll abbreviate that. The denominator. And let's move on to your calculator. Okay? What I want you to do is grab your TI-83, or if you're in Desmos, you can just make sure that you have degree highlighted. So what we're going to do is we're going to use our calculator to find the decimal approximation for each trigonometric ratio. And then you're going to round to 3 decimal places. So if you go to mode, click this button right here, go to mode, make sure that degrees is highlighted. And then what you're going to do, and I'll show you how to do this, we're going to enter in the sine, 63 degrees, the cosine of 47 degrees, and the tangent of 74 degrees. And we're going to do all this at once, and you're going to write those values on your notes, and we're going to come back to our notes. So grab your calculator. How do we plug this into our TI-83 or 84 calculator? I am having issues with my software program, so I'm going to use this method. The first thing that you need to do is make sure that you're in the correct mode. So you're going to click on mode and scroll down till you see radians and degrees. Because we're working with degrees right now, you need to make sure that degrees is the one highlighted. So use your arrow keys to make sure that degrees is highlighted. And then you can exit out of that, second mode or second quit, and that will exit out of that. So letter A says we're going to enter in the sine of 63 degrees. All you have to do, your trig functions are right here. And actually, you know what? I'm going to do something else. I'm going to highlight it so that you can see the buttons are sine, cosine, and tangent, and the blue words above it are sine inverse or inverse sine or arc sine, cosine inverse, and tangent inverse. And those are second functions, so whenever you need those functions, you'll press the second button first. So the first thing that you're going to do is find the sine of 63 degrees. So you're going to click on sine, and then you're going to type 63 and then just enter. You're already in degree mode. You don't need some degree symbol, so sine of 63 degrees. And you can round to 0.891. It's about 0.891, blah, 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 blah. So you can do that. And then the next one is cosine of 47 degrees. You're going to type cosine and then just 47 degrees or just 47 and enter. And you get about 0.682. 0.682. And then the very last one, you're going to type in tangent of 74 degrees. So there's tangent and then 74 degrees, 74, and you get 3.487. And that's rounded. I've already rounded that, 487. So these are the values that we got whenever we plugged in sine of 63 degrees, cosine 47 degrees, tangent 74 degrees into our calculator. So make sure you have this down. We took it out 3 decimal places because we needed to round it to some point, and this is typically where you do on your AP Calculus test. So it's good practice at this point in your upper level math. And now we're going to move on to solving right triangles. What does this mean? When we solve right triangles, we determine the degree of each angle measure, all 3 angles, and the length of each side, all 3 sides. So when you're solving a right triangle, you're finding every angle measure and the length of every side. What information is needed to solve a right triangle? You have to at least know one side length and one angle measure, just like this. You could also not know an angle measure, but you could know the lengths of 2 sides. That's all I would need. Now, this is right triangles. That's all I would need to find the length of that 3rd side and then those 2 angle measures. Or you could perhaps have a 1 side length and 1 trig ratio, which I have right up here. You could have a trig ratio. So let's move on to this example number 3. It says to solve triangle PQR, right? And that's how we name this triangle. We have the triangle symbol, and then we state the vertices, so PQR. So what do we have in this particular triangle? We know it's a right triangle, and we have the length of one side, which is the hypotenuse, and we have another angle measure. So that's just like this one right here. One side length and one angle measure. So I'm going to put a little triangle right there, or I'm sorry, that's not a triangle, that's a star made up of a bunch of triangles. So I'm going to put a little star right there because that's the one we're looking at, right? One side length and one angle measure. So what can we do? First, I know that this is a right triangle, which means this angle right here is 90 degrees. This angle right here is 52 degrees. And I know that the angles in a triangle add up to 180 degrees. So I'm going to write that down. The angles in a triangle add up to 180 degrees. Therefore, we know that I'm going to give this angle measure right there, we're going to call that theta because we don't know it. But I do know that theta plus 90 plus 52 equals 180. And 90 plus 52 is 142. So theta plus 142 equals 180. And how do I solve for theta? Subtract by 100. Subtract 142 from both sides. So I get theta to be 180 minus 32. I'm sorry, 180 minus 142 is 38. So theta is 38 degrees. So we've already solved for one angle measure, the missing angle measure. Now, can I use the Pythagorean theorem to find the lengths of the other two sides? I can't, because to use the Pythagorean theorem, I need to know the lengths of two sides, at least two sides, to find the length of the missing side. But when I know an angle measure and the length of one side, I can use a trigonometric ratio, which we know, SOHCAHTOA. So let's talk about this angle measure right here, 52 degrees. The sides, what are the sides called in relation to that angle? Well, this would be the adjacent side. This right here would be the opposite side of that angle. And this right here is the hypotenuse, right? Which is our longest side of our right triangle. It's directly across from that right angle. I know that the sine of 52 degrees equals the ratio of the opposite side over the hypotenuse. The opposite side is r over the hypotenuse. Now, why would I choose to use sine rather than cosine or tangent? Well, the trig function that you'll want to use will include one in your ratio will be your variable, like the missing length, and then the other one will have to be the side that you do know. Okay, so one of these needs to be a number, right? I couldn't use tangent, right? Opposite over adjacent, because that would be the tangent of 52 degrees would be r over p. Well, I've got two variables in this equation now. I only need one. I can only solve for the missing variable if I have one variable. So make sure you're using your trig function that at least includes the length of one side that you're given, and then the other side is the one you're looking for. So now I'm trying to get r all by itself. What do? I multiply this by 14. What I do to one side, I have to do to the other side. So what you're going to do is plug into your calculator and make sure it's in degree mode. 14 times sine of 52. Okay, and you're going to get r. So go ahead, pause the video, and plug that into your calculator now. When you do that, you should get that r is approximately 11.032. And that's the length of that side. So now let's find the length of the other side. And I'm going to change colors here just because. Well, actually, no, I'm going to keep it right here because I'm talking about that triangle up here that I've already labeled to be, or triangle, the star that I've already labeled to be purple. Okay, so now we're still looking at this angle measure right here, and since I know the lengths of two sides, could I use the Pythagorean theorem to find the third side? Sure, but what I'm going to do is use a trig ratio. I'm now going to use the cosine of 52 degrees, and the cosine of 52 degrees is the ratio of the adjacent side to the hypotenuse, which is p over 14. And again, we're using a trig ratio that includes one side that I don't know and the other side I do know. And we're going to solve it the same way we solved the sine. Multiply both sides by 14. And now in my calculator, I'm going to plug in 14. I wrote sine. 14 times, oh my goodness gracious. 14 times the cosine of 52. And I'm going to get p. So go ahead and pause the video and plug that into your calculator now. And you get p is approximately, and I can do my approximately, I didn't do equals, but approximately 8.619. That's the length of that side. And we've solved this right triangle because we found the length of the missing angle, or the degree of the missing angle, and the lengths of the missing sides. Let's move on to example number 4. In example number 4, it says to solve triangle XYZ. In this particular triangle, I'm given the lengths of two sides, but I am missing the angle measures and the length of one side. So That's a lot like this one right here. Okay, so that's like this star that I'm coloring in green. That's a lot like example number 4. Okay, so what do we do first? Well, what I can do is I'm actually going to label this missing side over here. I'm going to label it a lowercase y. Okay, and again, it's just this is triangle XYZ. And since this is a capital Y over here, the side directly across from it is typically a lowercase a version of the same letter. So we'll call that length, the length of that side, y. And when I know the lengths of 2 sides of a right triangle, what can I use to find the length of the third side? The Pythagorean theorem. So I know that a squared plus b squared equals c squared. That just means y squared plus the other side squared, which is 8 squared, or the other leg squared, equals the hypotenuse squared. So equals 14 squared. So y squared plus 8 squared is 64, and 14 squared is 196. When I subtract 64, I get y squared equals 132. And then when I want y all by itself, so I'm going to take the square root of both sides, and I get y equals the square root of 132. But I'm not going to leave it like that because that is a radical that I can simplify. So how do I do that? I've got the square root of 132. The biggest perfect square that goes into 132 is 4. So the square root of 4 times what is 132? 4 times 33. Which means the square root of 4 times the square root of 33 is the square root of 132, and the square root of 4 is 2. So I get 2 times the square root of 33. So that's actually how I would simplify the length of that side. 2 times the square root of 33. And I know I went pretty fast on that, but at this point, we've reviewed this year, how to simplify non-perfect square roots. So if you need a little help with that, go back to the radical unit for Algebra 2. So y equals 2 times the square root of 33, and that is the length of that side. So now, what am I going to do now? And actually, I'm going to stay green over here. I've got an angle measure, or I've got theta right here, and this is the angle that we're talking about. Okay, so we've got an angle theta, and I want to find what that angle is. I now know, or the degree of it, I now know the lengths of all the sides. So what could I use to find this angle measure? I could really use any trig function. I could use sine, cosine, or tangent. I just need to make sure that I write the ratio of the sides correct. Okay, so relative to this angle measure right here, I know that y over here is opposite. This 8 right here is adjacent, and then the hypotenuse has a length of 14. I'm going to use cosine just because. So I'm going to say cosine of theta equals, well, that's going to be the ratio of the side that's adjacent to the hypotenuse. Well, the adjacent side has a length of 8, and the hypotenuse has a length of 14. What I'm going to do is I'm going to use an inverse trig function. And so a lot of times what you'll see is inverse sine is sine to the power, or it looks like sine to the power of -1. That is how we notate it, right? Sine to the power of -1. So that's inverse sine. Okay, that's what we call it. You also might see it as arc sine. That is exactly how you will input it into your calculator. Sine inverse. Okay, inverse sine, sine inverse. So how do you find this? In this situation, you will use your calculator. When you've got your trig function or your trig equation written, and the angle is what you're looking for, and you have your ratio, what you're going to do is theta is going to equal cosine inverse of 8 over 14. And I'll show you how to plug that into your calculator. And then what you'll do, or Actually, you know what? Let's go ahead and do that. So go ahead and grab your calculator, and I'm going to show you how to plug this into your calculator. You need to type in cosine inverse 8 over 14 or arc cosine, arc cos 8 over 14. So that's right here, right there. And I'm using the second function, which means I'm going to press the second button first, and then cosine, and then I'm going to type in 8 divided by 14, and I'm going to press enter. And at this point, you should get, and I'm going to round it, 55.15. And that's how you plug that in. Equals 55.15 degrees. So this angle measure right here is 55.15 degrees. And now, do I need to use another trig function to find the other angle? I don't, because I know that angles in a triangle add up to 180 degrees. So what I'm actually going to do is I'm going to give this another Greek symbol right here, okay? And so I'm going to, that's alpha. And I'll just write this out, an equation that alpha plus 55.15 plus 90 equals 180. And then I'm going to add 55.15 plus 90, and I get 145.15 equals 180. And when I subtract 145.15, I get alpha equals 34.85 degrees. And that is that other angle measure. So I've got both of the angles, the missing angles, and the length of the missing side of this triangle. So let's move on to example number 5. In this particular example, which I think I used pink, I'm going to use that. We're going to solve triangle LMN. So in this particular triangle, I'm given basically that this is a, here's theta right here, and I'm given that the sine of theta is 7 over 11. That's the ratio, right? So sine of theta has a ratio of 7 over 11. Well, I know sine is, if I remember SOHCAHTOA, I know that sine is the ratio of the opposite side to the hypotenuse. So that means that relative to this angle measure right here, theta, the opposite side has a length of 7, and the hypotenuse has a length of 11. So now, let's call this down here. We know that this angle is m up here. I'm going to call this a lowercase m, okay? So now we need to use some trig functions to find these angle measures and the length of this missing side. So the first thing that I'm going to do is I'm going to actually find the angle for theta. Okay, so the degree of this. And I've got my equation written right here. If the sine of theta is 7 over 11, then we're going to use the inverse sine function, right? That means that theta is equal to sine inverse of 7 over 11. And that's what you're going to plug into your calculator now. Sine inverse of 7 over 11 is that angle for theta. So theta is actually 39.521 degrees when I plug that into the calculator. So I've got 39.521. What I can do is I can plug that into, I know that the angles in a triangle add up to 180 degrees, and I can go in like any order, but I know that this is 39.521 degrees. So this angle measure up here, we'll call it alpha. I know that alpha plus 39.521 plus 90 is going to equal 180. Right, if I've got two angle measures, or if I've got one angle measure and then I know the other is a right angle, I can find that third angle. So now let's add 39.521 plus 90, and I get alpha plus, I get 129.521. And then if I subtract that from 180, I get 50.479. So I know that that other angle is 50.479 degrees. So now I've got the three angle measures. I've got the lengths of two sides. Could I use the Pythagorean theorem? Sure. I could do 11 squared minus 7 squared, and that'll give me m squared. Could I use another trig ratio? Sure, and let's do that. I'm actually going to use the fact that this angle measure right here is 39.521. Now, remember that I could use the Pythagorean theorem, but in this case, I'm just going to use another trig function because I can, and I'm going to show you this. So I know this angle measure now because I figured it out. And I'm going to use cosine because I'm choosing to, or the side that I'm missing is the side that's adjacent to that angle. So I know I need to use, either the tangent, right, or the cosine because they have that adjacent side included in their ratios. Sine wouldn't, so I'm not going to use that trig ratio. So I know that the cosine of 39.521, because I know the degree measure, is equal to the ratio of the adjacent side, which is m, over the hypotenuse, which is 11. And now I want to find what m is, so I'm going to multiply both sides by 11. Remember, I know this angle measure, so I don't need to use an inverse trig function. So I'm going to multiply both sides by 11. So I get 11 times the cosine of 39.521. And when I pause the video and use my calculator to find that, I get 8.485. 8.485 is the length of that side. And so now we've solved this triangle because we found the length of the missing side and we found both degree measures, both angle measures. So let's recap what we've just done. We can absolutely use the Pythagorean theorem. Whoops, is this going to write it down? We can use the Pythagorean theorem to find the length of a missing side of a right triangle when you know the length of two sides. And that Pythagorean theorem is a squared plus b squared equals c squared. So again, like that example that I just did, I could have used the Pythagorean theorem. I just wanted to show you, how you could use trigonometry. So you can absolutely use the Pythagorean theorem to find the length of a missing side when you know the length of two sides. You're going to use a trig function, sine, cosine, or tangent, to find the length of a missing side when you know an angle measure and the length of one side. So relative to this angle measure right here, this would be the opposite side, this would be the hypotenuse, and this would be the adjacent side. Okay, so just make sure you label those sides correctly. So a little hint for this, you're going to use the trig function that would include the length of the known side, one that you know, and the length of the missing side. So the one that you don't know. So if you know that angle measure, let's say, for example, I could use the cosine of 76.7. And that's going to be the ratio of the opposite side, or I'm sorry, of the adjacent side, which is 3, over the hypotenuse, which I'll call h. Okay, so in this particular case, I know the angle measure, and I've got the length of one side included, okay, and then the length of the missing side included. So how would I do this? I would multiply both sides by h, and then I have h times the cosine of 76.7 equals 3, and I'll write this out. H times the cosine of 76.7 equals 3. So now what would you do to get h all by itself? In this case, you would divide both sides by cosine of 76.7. Cosine of 76.7. So in this case, you get h equals 3 divided by the cosine of 76.7. So we're just using algebra here, right? We're just undoing this equation, but this can be confusing for some students, many students, especially if this is the, first time you've ever seen this. I'm hoping that this is a review for you, but, if it's not, then I understand that it can be confusing. So let's move on. Then you're going to use, I'm going to change colors here. You're going to use an inverse trig function to find the degree of an unknown angle of a right triangle when you know the lengths of the two sides. So, for example, we'll call this theta. And your hint is to set up an equation. And if your equation is, for example, sine of theta equals 4/3, you're going to use an inverse trig function, okay? So I could say that the cosine of theta is, remember cosine, this would be adjacent to this angle, and this would be the hypotenuse. This would be the opposite. And so the cosine of theta is going to be the adjacent over the hypotenuse, so 3/13. And in this case, you're going to use an inverse trig function. So cosine inverse of 3/13 equals that angle measure, which is approximately 76.7 degrees. Let's move on. You're also going to use an inverse trig function to find the degree of an unknown angle of a right triangle when you know the trig ratio. So basically, this is the same thing as what we've just looked at, but the trig ratio, the cosine of theta, which is this angle measure right here, is the ratio of the adjacent side to the hypotenuse. So one of the big things with right triangles is make sure you label your sides correctly. The length of the adjacent side is 3 and the hypotenuse is 13. And now it looks like what we just did right above that. And let's move on. So this is our last page of notes. We've got a few application problems. And we just need to figure out what we're given and what the problem is asking us to find. So this number 6 says 40 feet from the base of a tree is a point that, oh my gosh, okay, 40 feet from the base of a tree lies a point on the ground. I will have to fix that. Hopefully yours is fixed by the time you read this or see this video. The angle of elevation, and I'm going to underline that, the angle of elevation from the point to the top of the tree is 62 degrees. What is the height of the tree? The angle of elevation means I have a base ray down here, like let's call this right here. The angle of elevation goes up, okay? So angle of elevation might look like this right here, or this. Angle of depression, that would be like the base. The base would be the top, and it might look like this, okay? So that's angle of depression. Angle of depression, just think about like goes down, angle of elevation goes up. So the angle of elevation is 62 degrees. We know this angle to be 62 degrees. What is the height of the tree? We also know that 40 feet from the base of the tree is the point on the ground, which means this right here, this purple line right here, from the base of that tree to the point on the ground is 40 feet. And this is the angle of elevation. Oh, my computer's getting tired. It's kind of lagging here. The angle of elevation. So we're looking for the height of the tree, which is this right here, right? We're looking for this, the length of that. So here we have a right triangle, and we know this angle measure right here. We know the length of the side that's adjacent to it, and we're looking for the length of the side that's opposite of it. So I'm going to write my little SOHCAHTOA, which I do on the top of every paper that I'm doing right triangle trig, and I'm going to set up an equation. What is the trig function that shows the ratio of the opposite side over here to the adjacent side? It's tangent. So I'm going to write the tangent of 62 degrees equals the opposite side, which we'll call B, I'm just giving it a letter, over the adjacent side, which is 40. And now I want to get b all by itself. So I'm going to multiply both sides by 40. That deletes it over here. And I've got 40 times the tangent of 62. When I plug that into my calculator, I get approximately 75.229. 75.229. And that equals b. And I'm going to erase this little dot right here. And I would write out, make sure I erase it. Therefore, the height of the tree is approximately 75.229 feet. And I'm not moving on to the last and final problem of today's lesson. Number 7 says, a man plans to zip line down a rope from the top of a carousel to the ground at the local carnival. The distance from the base of the carousel, right here, to the point on the ground is 90 feet. So we're going to label that. This is 90 feet. That has a distance of 90 feet. The angle of depression from the top of the carousel to the ground is 41 degrees. Now here's what's confusing for students. An angle of depression, I talked about an angle of elevation. That's from like a horizontal line on the bottom up, right? That's an angle of elevation. An angle of depression is when my horizontal line is on the top and my angle is coming down. So the angle of depression right here, if this is my horizontal line, which I'll just do this, the angle of depression right here is 41 degrees, which means this angle right here is not 41 degrees. Right here, if this were a 90-degree angle, and I mean that like this whole thing right here, if this whole thing was 90 degrees, this angle right here would be 90 minus 41, which is 49. So this has a 49-degree angle. So you have to be really careful about that. This right here, and I'm going to write it in a different color, this right here is your angle of depression. So I'm going to write that down. So the question says, how long is the rope for the zip line? So we're looking for the length of this side. So as you can see, this is my right triangle. Okay, and I'm actually going to erase this up here so that doesn't confuse you. Okay, so here's my right triangle. We're looking for the length of the hypotenuse. We know the length of this angle over here. We know the length of this leg, and we're looking for the length of the hypotenuse. So I'm going to use a trig function to figure out the length of the missing side, which relative to this angle right here, which trig function includes the side that's opposite of the angle and the hypotenuse. Sine, right? SOHCAHTOA. We're looking for the sine. SOHCAHTOA. That includes the opposite side to the hypotenuse. So let's write this out. The sine of 49 degrees equals opposite over hypotenuse. 90 over, and we can call that h. So I'm looking for what h is. Well, I need to get h all by itself, but the first thing I got to do is remove it from the denominator, multiplying both sides by h. So I get h times the sine of 49 equals 90. To get h all by itself, I'm going to divide both sides by the sine of 49. So h is going to be 90 divided by the sine of 49 degrees. And you can pause the video and plug that into your calculator now. 90 divided by sine of 49 degrees, which means h, the hypotenuse, is approximately 119.251 feet long. So therefore, the length of the rope is approximately 119.251 feet. And that concludes your notes over a right triangle review. I hope it was helpful.